right. Let's see if this works. Wait for it, wait for it. And another. Let's get rid of that. All right, hey everybody. How's it going? Hope you are doing well today. I'm going to run you all through kind of the basic project structure of a project in Zephyr. Before we do, though, of course, be sure to do all the things, and I really appreciate it. And we'll jump right into it. So here's a, if I zoom in here, so here's a kind of overall structure of a Zephyr project if you're just looking at your kind of application code side. So typically the way I like to design applications is I will put it into a separate app folder. So you can see that app folder here, and you can see all the files that are application specific. They're all living in here as well. So we'll dive into those details, especially, you got the West manifest, the CMake lists, and the KCONFIGs. Those are all probably the most important ones we'll be dealing with. And then I'll clone a project in a bit. We'll just run through it in a little bit more detail. So we have the West manifest, and this guy is essentially, if you guys have ever done or used Git submodules, it's a very kind of similar concept, whereas Git will manage the Git submodules. You are managing all the dependencies for your project within a YAML file called west.yaml, or YML at the end there. And this essentially pulls any Git repo that you like and deposits within your project. So you might have a driver or NRF Connect SDK, or just plain old vanilla Zephyr or library. All those things you can call out in your West manifest, and then you can pull it into your project. As you expected, that from last week, I introduced West. And West is our go-to tool for pulling in project dependencies before you get started programming or whatnot. And you can also use West in this case to use the project manifest to actually initialize the project from scratch. So say you have a new developer coming on in your project, you can give them access to the repository, and then you can have them just do a West init, and it'll actually pull down the project for them, set everything up. The only thing they need to do on their end is set up toolchain, Python. Of course, you have to have that set up beforehand, and things like that. So it's, once you have an environment set up, you can just do this over and over and over with different projects. I've gone from questioning it to going, man, this is fantastic. I just wish it was easier for people to get started with. And here is a very simple West manifest, and it's only pulling NRF Connect. So NRF Connect itself, if you actually take a look at their manifest file, it's much more complex. It's pulling Zephyr. It's also pulling some outside repositories and dependencies. But for this case, I'm just using version 1.7. And the important thing here to note is that if you look at the self path, that's the name of the app where the application should be cloned to or initialized to. Whenever you're building an application, you want to make sure that the path of your application matches that self path. Definitely made that mistake multiple times, so it's easy to do, and then you just fix it and you move on. So for CMake lists, they are used to configure which files you're going to include in the build process. I think many of you are already familiar with CMake, so I'm not going to belabor it, but it is different from compared to, let's say, Nordic's original SDK, where they're using make files. It's kind of recursive to some extent, where it traverses file structures within your application and determines what the dependencies are, what files need to be compiled. Creating also like environment variables can be set in CMake, and also running scripts. For instance, I have a kind of CMake, I guess you could call it a script, where you can run the git describe, and you can actually get the version from the tags in your Git repository, and that will basically get imported, and then you have access to your Git describe info. I use that for determining what version my firmware is. It's kind of my way of, instead of using like a configuration file where I'm like manually changing the version number of my application, I can just change it once in Git, and then I can rebuild and it'll format the version number correctly. If you are interested in something like that, I can definitely run through that in maybe a next video. And oh, hey Robert, just looking at the comments here. So if you guys have any questions, feel free to drop them into the chat box and just let me know, and we can run over questions at the end. And let's see. So here is a very basic example. Actually, there's a lot more in this file, but I kind of remove that for now because this is a very basic CMake list where at the top you're calling in Zephyr. Then you're naming the application. And actually, before that, I left out, but typically you want to call out what CMake version you're using. And then you go from your project name, that can be whatever you want to name your project. And then if you have subdirectories where you have sub CMake list files, then you can actually add them here using add subdirectory. And finally, if you have multiple sources or just a single source in your project, you can just call them out using the target sources function. So I'll show you what some things look like once I pull down this example in a bit. Then you have your KCONFIG. So these are used to set up the project or sub-module specific macros and variables. So entries in the KCONFIG can be invoked by West. You can actually get like a GUI type command line. I first used this a lot when I started, but now I barely ever use it. Mostly because any variables or any config variables, any variables or macros that start with config underscore, they all live in your .conf files. And you can set whatever those variables are in all your different .conf files. Your default .conf is your prj.conf. And then if you go back to your CMake list, you can actually define other .conf files that you want to use in Zephyr. So you can break them out into maybe debug versus release, or you can add in, like, for instance, sometimes I'll add in a backend .conf just to keep all the backend stuff separately. Then you also have board specific .conf files, which also you can essentially call it any kconfig variable and put them in any of these .conf files, as long as the CMake, your CMake actually knows where those .conf files are and how to look them up. Again, very basic kconfig. We're starting at the beginning here, but you have like a main menu, and then within the menu you're pulling, if you have defines, and I'll show you what the source version kconfig. So basically that R source, you're pulling in that particular kconfig file, and then most importantly is make sure that you source the kconfig.zephyr, or else your builds will not work. And then here's what the kind of inside of the version one is. So config app version, this will be like for instance, this is the string value of the git describe -- tags, and that will show up, that'll get set here. So when you're using it in your code, it's gonna be all uppercase config underscore app underscore version. And it goes for the same thing here throughout the kconfig. So a lot to take in, but we can pull the template example, and then I can show you guys what what I'm working with here in terms of these KCONFIG variables. And then let's set up the project. I'm going to zoom out. I'm going to change over to VS Code, and then I'm actually going to set up a, make sure this is working. Yeah, so I'm going to set up a virtual environment. Normally, like if you're using Nordic's NRF Connect Studio or an SDK, they've already created the Python environment for you, but since I'm doing a lot more projects where I don't want to share that same repository, I am going to want to create my own Python virtual environment. And it just keeps things sane when you're moving from project to project, because I might have one project using NCS 1.5 or 1.4, and now I'm using 1.7, so it just keeps everything sane. So I'm going to source and activate that fish. The fish script, I'm using fish as a terminal here. And then pip3 install west. So we're going to install west. And let's see, questions. Hey, Johan. And then let's see, Zephyr has some of its own CMake commands for adding sources. Generally, what I've done is I always, to answer that question in the manifest file itself, I've always set what sources I need from there. So if I do a west, so I'll pull this down and I'll show you guys what it looks like. So I know hopefully that's not too small. I think you guys can see that. But we're going to run the west init -m, which is for manifest, and I'm going to be pulling this particular repository, and it should create a copy of, it should basically clone or not clone, but check out that repository. And if I go to app, so it created it in app. If I go to app and then west YAML. So if I wanted to create more entries, then I would just basically go here and then change this out and then add new dependencies. And typically, if you want to, let's see, like you can set your remotes up here, but there's also another way of doing it where you can actually just set the path to your whatever dependency in here, so you don't have to add it up here. I believe it's just if you just remove this, it's just path and then just like the full GitHub repository link. And then, but it's a little tricky. Maybe we can go into that. Maybe we can dive a little bit into that in a little bit. I can show you what it looks like in the Nordic, on the Nordic side. Now I've already initialized, but I do need to update and pull all the dependencies, so that's going to take a minute. So once we get the NRF directory, then I can show you what the west manifest looks there, because then you can kind of see what I'm working with. And hopefully you guys can see that, and maybe you can make it a little bit bigger. But you can see that they've added a ton of different remotes, most importantly being like Zephyr. Then you have, their particular URL plus a bunch of other things, ARM embed, Alexa, Nordic Semi, probably another set of dependencies for Nordic stuff. Pulling in memfault stuff, Pelion. So you can see, if you want like a good example of how to pull in more code into your project, this is like a good thing to look at. You can also look at NFED, which is my NRF 9160 Feather examples and drivers, and that will have a bunch of stuff in there. I wonder if I can. I don't think I can change over, and let's see if I can do it. Let's see if I can change window here. Cool. Change the window real quick. So here is what I was talking about before. Oh, I just made the wrong window open. But you can see for like, wrong one. Endfed. We want endfed. Okay, it's called URL instead. That was a little bit, it wasn't path, it's just URL. But you can see I've set up a remote. That's for pulling down the NRF Connect SDK, and then I've called it out here in the project. So important here, you're calling out the particular revision, and you're calling out this remote links to the name up here. And then the repo path is the actual name of the repository on GitHub, so it's the part that's after it. So it's really calling out like SDK, NRF.git, but instead you're defining it a little bit lower down here. And then one thing I haven't mentioned yet, but the import. So import will actually, if you have like multiple submodules or things that are, or maybe if you have, better way to say, if you have nested West manifests, if you don't have the import :true, then it'll only pull the top level. But if you do have it, so if you don't have it, it'll only pull the top level. If you do have it, it'll actually recursively pull all your dependencies depending on the West manifest and the lower levels. You can also see here in Purinas using the URL rather than referencing it in a remote, and then revision again, very important. And then these path variables, this one doesn't have, the NRF one does not have one, but path will actually dictate where in your folder structure you want to put those files. So in this case, I'm just putting Purinas in the root, and by default, I believe NRF also goes into the root of the project. So that's it for that. So it's chunking along here. I think it just finished. Let me switch back to the other window. If I can do it. Oh no. I'm gonna switch back. Let's see. Perfect. So we've built we've actually pulled all the dependencies using West update. And then what we can do is, the next thing you want to do, especially if you just created a new virtual environment, is make sure that you pull in or you install all the Python dependencies that Zephyr requires. So pip3 install -r and then into Zephyr scripts requirements.txt. Make sure you guys can see that. Okay, you can. And this will actually install all the dependencies that Zephyr requires. I'll let it chunk along here. And then once it goes over, then we can run and try to compile our application using West. Should take another second here. My computer is lightning fast. So those screenshots earlier were all the things that I took of this exact project. All right, excellent. So we'll change to the app, and then we'll build a Circuit Dojo NRF9160 Feather, and that should chunk along here. So oh yeah, so you guys might run into this error, and essentially what Zephyr is complaining about is that you have not defined what toolchain you want to use. Depending on what chip you have will determine what toolchain you're using. In my case, I use GNU RMGCC, so we'll just have to export that here, and this is already saved in my command line, so it's easy for me to look up every single time. If you actually look in my CMake lists file, I also had it so I can actually just like set it permanently, so I don't have to do this every single time I open the project. This might not work for you guys if you're working with people who are using or developing on different platforms. So say you're on Windows and one of your other developers is on Mac or Linux. Those setting up those environment variables will obviously be very different. But you can, if you're feeling lazy, you can set it in the CMake list and not have to deal with it. But in my case, I'm just going to set it manually here, and then should be able to build it now. And then Millie, there are problems doing here's another question. There are some problems doing Zephyr and CS Dev on Mac. I usually use Linux. So actually they're very similar, and setup on Linux is actually a lot easier for Zephyr. Zephyr is a Linux Foundation project, so there's like kind of first the support for Linux is pretty good, but I haven't had any issues when I'm doing it this way, the way I've just kind of described how I've set it up. I haven't had any problems. If you are like pulling in their SDK from their SDK manager or something like that, or I know customers come to me and sometimes and they're like, hey, I want to use this with like Seeger Studio, and it just gets a little hairier then, because you have to buy into Nordic's kind of environment and their setup. And if you foresee yourself maybe going to another chip or another platform, but you still want to use Zephyr, then you probably don't want to be diving in too much or utilizing Nordic's kind of tool chains and things like that, because you'll have a headache later on when you have to just remove it all. So I'm a VS Code guy, so I just use VS Code. It's worked for me for a while now, after switching from Atom like 2 or 3 years ago. So, but cool. We just had a very successful build here, and make sure you guys can actually see that happen. So yeah, if you guys watched my video from last week, this should look pretty familiar. We've created a merge.hex, which includes the bootloader, partition, our secure partition manager, and also the application. And one thing I will show you, because I alluded to it earlier, is so this is kind of like what the can I hide this? I guess not. I'll just put it down here. So this is the crazy Git script that I'm using to pull the version, and it's just running a git describe tags long, and then what it'll do is it uses regex to get all the version information, and then pops it into a configuration variable or a configuration file called version.conf. So if we actually go over to version, if we go to conf and then version.conf, all this stuff gets generated automatically. So you get to use all these variables or macros within your application, as long as CMake is actually pulling in those variables. So if you go back here, so if you guys saw like before, like we were only dealing with like this part of the CMake list. It's actually a lot more here. Once you like, that's why I recommend, like, if you want to just get started, like, you know, you can get started just by using something like, just by using like these. But as you get started, you got more configuration, and you want to customize. This is where you can kind of bring in different files. So I'm bringing in this version.conf very early on in the process. If you do want to bring in any of these .conf files, make sure that you're doing it before you're calling the find package Zephyr required hints, so on and so forth. Because what it's doing is you always want to build your application configuration before calling Zephyr, because otherwise if you call this find underscore package before you define those variables, then they won't be used later on during the compilation process. So it's just another thing that you just gotta, another gotcha. It's just like, oh, okay, I just need to make sure that this is there beforehand before I start building. So just another gotcha. So that, let me see, what else have we not talked about? So that's not any different, and this guy is not any different. But I can pop this guy out a little bit more, and you guys can see. So what I've done is, whenever you have dependencies or submodules, you can create its own CMake lists and KCONFIG files, so you can kind of keep them compartmentalized. And so the KCONFIG will always reference any sub KCONFIGs, and the CMake list will always reference any subdirectories. Or when you're adding subdirectories, you're actually targeting the CMake list file in that directory. And then you can see we're including the directory itself, so we're including it really for the app version.h. And then for the target sources, you then you can actually set the C file that you want to compile into your application. And then, because I'll show you in a second here, if we didn't include any of those in there, this build would fail, because we're actually referencing in this main file the config_app version, and without that you wouldn't be able to access the file, the variables generated here in the KCONFIG. Let's see, questions? Cool. That is about it for the structure. And you can kind of go as deep as you want with modules and things like that in your source folder, and then also in your configuration folder. I like, sometimes if it's a backend, you have multiple different backend configuration files. You can create your own backend folder. Some of these folders are checked by default. So for instance, the boards directory within your application, that's checked by default by Zephyr. So there, you don't have to add anything in here. When you start calling out, if you start calling out some of these more custom, like the debug.conf, version.conf, you might have to actually call out the board specific configuration file, just because you're overwriting what Zephyr does by default with the command I showed you earlier. So if you go back here, this list append config file will actually, as far as I can tell, it doesn't append. It kind of destroys your list of configuration files to look for. I think there might be a way to do this where it doesn't destroy it, but you can see down here, I actually add the boards, and then this board variable actually gets populated with whatever board you're building. So if you do like a west build -b, that's what it's referencing. So this board gets populated by this -b. And then this build type, if you're curious, is actually just a variable that I set by default up here. So by default, it's a debug variable. And then if you want to change it to something different, you can actually, if you look down here, so you can, if you want to add a build variable, or a macro at build time, you can do -- and then many of you know about it, the $D to create like a variable at compile time here. So I'm actually just setting the build type to equal release, and that will override anything here. So it actually build as a release versus debug by default. So also very handy, because it took me a while, like, oh, okay, I need to figure out how to set the release mode, or else I can't change it from debug. So just another thing to think about, especially if you start getting more complicated in your project setup. So all right, so let me see if there's any more slides. Nope, that's it. So if you guys have any questions, feel free to shoot them over, but that's it for a project structure. Hope that has helped you guys, and see you on the next one, I guess. Let's see. Any other questions, folks? And thanks for being here. I really appreciate it. This is awesome. Thanks for coming. All right. Well, if you do have questions, you know how to find me, and I'll leave the info in the show notes. You can always contact me, and we'll go from there.